All right, we're moving along the transformation train. So we've done A, we know what it does. We've done B, we know what it does. Now we get to move on to C. Now C and D are way easier. I think it's why the textbook starts with C and D, but I'm like, yeah, but when you're doing transformations, you have to do A and B first. So if I can ingrain in your brain that A and B happens before C and D, that's nice. And it's also nice when things get easier, right? It's always worse when things get harder. So the first thing we're going to do is explore what this value of C does. So I'm going to open up Desmos. I haven't cleared this from the last time, but I'm just going to go like this. Let's choose y equals, let's go the absolute value of x graph. So let's go absolute value of x graph. Okay, so there's my base graph. I'm going to put my transformation in the bracket with x. Now, absolute value signs are brackets, so I'm going to go y equals the absolute value of x minus 3. Where did my graph go? So my red graph is y equals the absolute value of x. My green graph is the absolute value of x minus 3. Where did it go? It went to the right. Oh no, it's all the way over here. What does that mean? Well, it did the opposite as I thought it would, right? Everything with x is opposite as it appears. If it looks like minus 3, go to the right 3. Why? Well, again, we're trying to get the same y value, right? We don't want this y value of, let's say, 1 to change. And so if I want to get a 1 in here, normally for this one I would just put in x is 1. But to get 1 in here, I actually have to put in an x value of 4. I had to increase my x value by 3 because the equation is going to decrease it by 3. And so when I increase my x value by 3, I then subtract 3, take the absolute value, and I get the same y value. So everything with x is opposite it appears because it happens before you do the operation. Okay, so if I was to plug in y equals the absolute value of x plus 3, where is it going to go? It's going to go to the left. So this C transformation follows our same train of thought. Anything with x is opposite as it appears, and we just move things left and right. So if the C value is greater than 0, the equation is y equals x minus c. So if you put in a C value that's greater than 0, it's going to look negative, x minus 3. The graph will be shifted right, opposite as it looks. If it's x plus c, so if you put in a c value less than 0, it would be minus a negative number, which make it look positive. It's going to get shifted to the left, c units. From an equation standpoint, a transformation on x goes in the bracket with the x. So from a function point of view, you just go f of x minus 2. From an equation point of view, you put it in the bracket with the x before an operation happens. Okay, let's do some transformations. So if I have a point 2,4 on a base graph, I want to describe how the graph of the function can be obtained from the base graph and find the corresponding point. So let's start with the point 2, 4. This is a transformation on x, and it's going to make me add 4. It's going to go to the right 4. So the transformation is that it's going to have a phase shift, or just it's going to shift right 4 units. Okay, so if I have my point 2,4, I'm going to add 4 onto my x value, and my new point would be 6, 4. Same idea here. If I have a point 2,4 on my base function, this is going to tell me to subtract 2. Okay, it's going to move my graph left 2. In other words, 2 minus 2 is 0, 4 would be my new point. All right, pause the video, try this last one. So I have the point 2,4. This is going to get me to subtract 3 from my x values. It's moving my graph left 3. So if I subtract 3, my new point would be at negative 1, 4. All right, let's see 2 in action. So let's start with a transformed base graph. So this is a graph that we don't have an equation for. We just call it y equals f of x. This is telling me to graph y equals f of x minus 3. So hopefully you can see that's going to shift it right 3. So I'm going to take my x values and I'm going to add 3. So let's figure out what our key points are. There's one there, 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 there. Actually, this one will be okay because it's right. I often find this kind of a graph that has the swoop or the curve, I could never, like if I only do these 2 points, I'm like, do I draw the curve this way or this way? Because this is shifting left and right. I don't need an intermediate point. But if I was reflecting it or doing anything, I would pick another point somewhere in here. But let's pick those points I picked. So -5, 2. The next one is -2, 2, 0, 4, 3, -2, and 4, 1. Okay, so to each of these, I'm going to be adding 3 onto the x value. So my new point will be -2, 2. In other words, I'm taking this point -5, 2, and I'm shifting it 1, 2 units to the left. All right, this next point, oh, did I just say 2? Oh, catch me. What did I just do? I'm shifting to the right. Sorry, I think I turned my brain off for a second. I'm taking this point -5, 2, and I'm shifting it 3 units to the right. 1, 2, there it is at 3. So that's a point -2, 2. Then I'm taking my next point, and I'm adding 3 to the x value. Falling apart here. That would be a point 1, 2. So again, I'm taking this point, I'm moving it right 1, 2, 3, and it would be at 1, 2. And I would draw my connecting line at this point. Then my next point, I'm going to add 3 to the x value, and I get 3, 4 as my transform point. In other words, I'm taking this guy here and moving it right 1, 2, 3. There's my next little part of my graph. Then this one, I'm adding 3, I get 6, -4. In other words, I'm taking this point and moving it right 1, 2, 3, and I get that part of the graph. And then lastly, I'm going to move this guy right 3, and I get a 0.71. In other words, I'm taking this point here and going right 1, 2, 3. So I kind of did a combination here. I did my points, but I also just took the graph and moved it right 3. So saying that you're one method or another doesn't have to stick, right? Just because I'm a points person doesn't mean I have to do a points one for this one. Because it's just right 3, I didn't have to do all this work. I could have just taken each point and moved it right 3, right? Right 3, right 3. And I can see that shift. I can see that transformation of right 3. All right, next one. Again, I've given you the base graph. In your homework, you're going to be expected to come up with the base graph. So this is my y = x cubed graph. So it starts at 0, 0. It's got a 0.11. Then the next perfect cube would be 8. The cubed root of 8 is 2. So that's up here. And then I get the same thing, -1, -1, and -8, -2. So those would be my key points if I was going to transform them. This graph is going left 2. So if I want to, I can take all these points, I can write them out, I can take my x values and I can subtract 2 from each of them, or I can just physically move it. So let's take this and let's take each point and move it left 2. So my scale, I can't move that point. So I'm going to move this point. So 1, 2. Right? And so by moving left 2, be very careful what the scale is. This scale is a half, so it's not moving 2 grid lines. It's moving 2 whole units. So from -1, I'm going to -3. So maybe I should write that down, right? So if we were going from a point of view, -8, 2 would go to -10, -2. Right? -1, -1. If I subtract 2, would go to -3, -1. So I have to make sure that I'm staying consistent with my grid. So this point here, left 1, 2. This point here, left 1, 2. And then this point here, 1, 2. Then I know that it gets this swoopy shape over here. And then it gets the same swoopy shape over here. So just in case anybody's just looking at these notes keys, I'm going to fill this out. If I go left 2, this would be at -2, 0. I have a 0.11. Left 2 would go to -1, 1. And then my 0.8, 2 would go to 6, 2. All right, so again, from a points point of view or just shifting the entire graph to left 2, this is the first transformation, or the first of 2.5 part 2, so the second half, but it's a transformation on C. So go and do the worksheet numbers 10 and 11, and then these questions from the textbook.